Okay, testing, testing, 1, 2, 3. Can I have confirmation that I am actually streaming? Oh, an error occurred. Please try again later. That's a good start, isn't it? Okay. Well, for whatever reason, it's not actually... I wonder if I did this. Just bear with me a second here. Not without technical issues. Right, that looks a little bit more like it. Okay, alright. So, I am going to do a live recapping of a Macintosh LCIII. Hi Steve, hi Jay. Steve, this is not meant to be a personal attack, okay? I have mainly chosen this one because it is in such poor condition. And so I wanted to actually, the main reason for doing this is that I've actually had a few people contact me about sort of recapping that have been struggling with some of the methods that I've been describing. Thank you. I'm glad the quality and the picture and audio is good. I'm pleased about that. That's nice to hear. The thing is, in one of my very first recapping videos, I did actually say, if anyone who's wanting to give recapping a try, have their first try at it, you kind of need to pick your battles, and it's also not a bad idea to do a lot of practice first. I'll just give you an example. So I'm just going to quickly flick over here to the microscope, and I am just going to go, hey Grudy. So yeah, this is let's just go here to the microscope very quickly. Now this here is an LC475, and what you'll notice here with all of these little pins, that they're all looking nice and shiny, and if I were to actually put a soldering iron to those and knock stuff over, put a soldering iron to them, that solder would melt. You can see it sort of melting there, and that would be a really good candidate for sort of a nice easy recapping job. This one on the other hand, and keep in mind that this one is particularly bad, I think this is probably even worse than the one that you were looking at, Steve. If you have a look here, you can see there's a lot of rotten scunge and stuff, and I mean this little resistor here is just looking really, really grotty. And then if we have a look down here, if you look at, say, that joint right there. Now, if I was to put a soldering iron to that, absolutely nothing is going to happen. There is more corrosion there than there is solder. And that's where I would say, if you've got a board that looks like this, you're probably better off either, making sure that you have the tools like a hot air gun to remove it, or sending it to someone else to do, because when it looks that bad, it's, trying to just get that off with a soldering iron is not going to be a fun task. So what I'll do is I will take this off so that we can just at least see what the pads look like underneath. So I'm going to get my little my little heat shields in here, just because this is surrounded by plastic and I don't want to melt everything. Easy said than done. There we go. Have I managed to do it there? Close enough. Okay. Alright, let's try that. I'm going to have to spin it around, I'm afraid. Spin around. Alright. Now, I don't actually really expect the kind of the solder to properly melt here, because it is in such bad condition. But I'm just hoping I'll be able to get enough heat there that I can then poke it off. It's actually starting to blow up, this one, so starting to pop. Ouchie. Hey, off she comes. So let's now go back and have a look at that. And as you can see, that one is really, really scungy. Where do you get your heat shields, or what do you use? That is a very good question. And what it actually is, I'm just going to go. These are the little blades, the little snap-off blades that you get from like a box cutter type thing. It's actually, yeah, that's what you use to do scraping, Steve. When you want to scrape off, the grot off the board. So it's just those, and then I just cut them to different lengths. So and then I use springs like this. A spring there that I then hook over the edge like that, so that they then stay upright when I put them on the board. I can just plonk them down to the board anywhere. You can put them on the bottom like that. So anyhow, they're really, really handy things to have, and they absorb heat really well, and they sort of protect the plastic components. And even when it comes to things like removing, removing components and people not wanting to have damaged serial numbers, which is fine. I quite understand that. I don't care about serial numbers, but I expect that some people do. So I then will often sort of stick one down onto over top of the serial number like that to keep it protected while I've got the hot air station. So that's basically what I use for my heat shields, and so then I shall now move along. This is tricky, isn't it? Sort of reading the comments and working at the same time. So flux, Amtech flux in a syringe, a lot easier to get out than sort of scooping it out of a little tub, but not that anyone needs to know that. We're all aware of that, so no more will be said about that. And then I'm just going to put some flux liberally onto there, and then of course add the new solder. I use my cheap solder for this bit. I've got expensive solder over here, but I just use the cheap stuff because I'm just going to wick this off. So, and this is leaded solder, or always use leaded solder. Lundo's. Hello, Lundo's hair. Who's Lundo's hair? I don't know everyone's names who have these nicknames. Okay, so just going to add this solder to the crusty old stuff, and I just keep moving around like this. And this is actually a step. Oh, I've got to change it to the big screen, don't I? This is the oh, that's Dana. Hi, Dana. So this is the sort of the bit where you really need to be careful. So one of the things that I keep sort of talking about is the importance of flux, because you can actually see this here. You can see how this solder is starting to get a bit of a film on the outside of it, and that's because it's oxidizing, and that's what the flux is for. The flux is to stop that oxidization, or oxidation, depending on what country you come from. And so the flux is a really, really important part of this, making sure that solder stays nice and molten and shiny like that. Now, when I keep moving around like this, I'm using heat, I'm using solder, and I'm using the flux to get this pad sort of cleaned up. And as you can see on this one here on the right, there's still quite a bit of crust all around here. Now the idea is that I just keep gently rubbing this, and when I say rubbing, I'm barely even touching the pad. I'm virtually just hovering above it, but I'm barely touching the pad, and I'm just rubbing backwards and forwards. And what I'm hoping to do is use that heat to make that crusty stuff sort of break away from the pad there. Now, having said that, there is a point where you just go, no, that's not happening. And that's where I will then get my wick, my solder wick, my braid, and a cutter. I'm doing my best to remain entertaining, so I apologise if I get boring. I'll start doing impressions. Okay, so just gently, again, really gentle. The big problem with, how do you remove the little black spots? That's something I struggle with. Yeah, well, that's where the blade comes in. So, or are you talking about the black spots as in kind of like the corrosion around here, or are you talking about this black scunge on the end here? I'm assuming you're talking about this black scunge. And that's where the blades come in handy. So these are the these are the blades that I use, and they are just going to go back again. These are surgical scalpels. I first started using them when I used to work in a design studio, and paled myself on one once upon a time. But they are incredibly sharp, obviously because they're designed for cutting skin. And these ones here in particular, it happened when we used to always use straight edge ones, and then one day we got a delivery of curved ones by accident, and I found that I really liked them because they were so good at scraping things. You know, if we were trying to, you know, back in the old design days, we used to have sort of you know, bromides that had black, you know, sort of printed stuff on them, and you could scrape little bits of it off if you wanted to. So anyhow, that's what I use, you know, with the curved blade. So when I get to a point like this, where I've had a go with the flux, and I've had a go with the wick, and I've still got black scunge there. I'm just cleaning this off with a little bit of iso alcohol, because I've let it dry. It's gone kind of really, the flux has gone quite hard there. Spots on the green, and sometimes what raises to the top of fresh solder. Yeah, I assume it's leftover capsicum. Yeah, so you end up with this sort of crusty film over the top. Now, the little green spots all over here, like somewhere here, I wouldn't really worry about because there's lots of surface area, lots of copper still there. But there are some areas here that worry me on this board, where, see, you've got, you know, little spots along here. I'll move that up in the camera. Unfortunately, I see a lot more through this microscope than shows in the camera, so I apologize if I miss at any stage. There was one spot I was looking at before. Where is it? Yeah, see, we've got all these little dots here which don't fill me with confidence, because any one of those, if it's broken through the copper, you know, we're going to have to go in and repair that. And then looking at this here, I mean, you've got something like that there. So there are two ways you can deal with those sorts of things. You can just hope for the best, hope that they're still making contact, and pretend you never saw them. Or you can kind of scrape off the coating, but obviously if you're going to scrape off the coating, you need to then do one or two things. You either need to tin it, or you need to coat it with some UV mask afterwards, because if you just leave that copper exposed, it will corrode. And in the instance of these ones here, these will continue to corrode. So, you know, I can't say that I will necessarily go and clean up every single one of them, because at the end of the day, you know, it could end up taking a really long time and then cost a lot. And at the end of the day, this is a Mac LCIII. Thanks for that, Gritty. I really appreciate that. I'm sure I've got the ability somewhere to see how many people are watching. Oh, 9. I've got 9. I've got 9 viewers. That's extraordinary. Thank you, everyone. So anyhow, that's the issue that I'm going to have with this one, is just how far do I go with the cleaning up of a lot of these corroded traces. But the first thing I'm going to do is just sort of deal with this little black scungy bit on the end of this pad, and sort of, I've tried my normal cleaning methods and I've still got that behind, so that's where I really need to get into the scraping side. And again, very gently with this, you just need to try and get rid of that. I need new blades. Sorry, this one's got little gaps in it. Now I just need to find where I've got all my blades. I've got a box of them down here somewhere, and I've put them somewhere. I put them here. So these are the replacement blades. They're actually sterile. Because they're used for surgery. You can buy non-sterile ones. They come in a blue box. The sterile ones come in a red box. But the reason why I got sterile ones is because I found someone selling 3 boxes of these on eBay for incredibly cheap, so I just bought all of them. Okay. Alright. So, let's just swap this blade over. Yeah, I don't actually use many of these tools for repair. Some of them, see this one. This one's great if you're wanting to do a RAM upgrade. I'm going to do a video on that later on. These come in really handy. Okay, so back to scraping. So I've got a nice shiny new blade on there. Look at that. How shiny is that blade? That is shiny. Right, so scraping away at this gunge. And what I want to see at the end is shiny. Whether it be shiny copper or shiny solder or whatever, it doesn't really matter. It just needs to be shiny. And we can see that all coming off there. There we go. Lovely. Looking much better there now. Alright, so then a little bit of flux back on there, a little bit of solder, a little bit of wick, and there we go. That pad's looking a lot better, a lot readier. Sorry, I'm a little bit out of camera there. A lot readier for is that a word? For putting a new cap on. So that's sort of that is really the most important thing. I mean, when you and I do see this when people have sent me recapping attempts, and I see that they've tried to put caps onto a board that hasn't been properly cleaned. It just makes your life so much harder when you've got pads that look like this. The solder is just going to take to it so much easier. So anyhow, that's now next bit. We've got to get more of these caps off. So we're going to. Actually, that is something I did want to mention, because this is something that someone commented to me about, and I think it's really important to mention. Yes, the most of the guns on this is electrolyte juice, but it's then actually caused a lot of corrosion. So most of what we've actually got here is, like really heavy sort of corrosion and oxidization from that gunk being spilled. So yeah, the really important thing I did want to mention about the old solder wick, because I just, when I jump onto my sort of videos, I just grab it and I go, yeah, away we go, wipe, and it's all done. If you've never used solder wick before, one of the real tricks is that if you're using it and then you take the iron away, it solders onto the pad, and then if you just give that even just a gentle touch, it's going to take the pad away with it. So my recommendation, is always you've just got to always make sure the iron and the wick stay together so that they are hot. And then you move them away from the area of solder together and then lift it up. Because obviously, if you take the iron away and leave the wick there, it will stick to the pad, and then you'll be in all sorts of strife. Alright, okay, so got to take a few more caps off. So I'm going to get my little sort of heat shield things back here. And these ones in the corner here are a little bit tricky because they're kind of tucked in there, but I'll just do that. I really hate giving people's boards back with melted plastic. So incidentally, anyone who has a quick 861DW hot air station will be well aware of the fact that when you fire it up, the lights kind of dim a little bit. It's a bit of a power hog. Oh, see, look, I'm melting. I am actually melting plastic now. And that's exactly what I said I didn't want to do. Oh, there's one. And there's another. Okay, so they're both off now. and I'll just show you where I melted slightly. Is just there. Now, one little trick which I have learned from very occasionally melting plastic, it doesn't happen very often, but when it does happen, what I do is I get my super sharp little scalpel and I try and just shave off the bendy bits. And it doesn't look quite as bad. It looks a little bit straighter and a little bit more deliberate. There we go. But I'll tell you what, you might see it under the microscope, but it's not the sort of thing you're going to see when you're not zoomed in. Okay, so there's 3 more caps off. I mean, I would normally, when I'm doing this, take all the caps off first, and then do all the cleaning, and then do all the recapping. But yeah, I know, molten plastic. I know, it's a disgrace, isn't it? Don't tell anyone. I blame it on the live stream aspect. It's the pressure. Okay. And this is the famous C22 that many say is on backwards. I am still not convinced of that, but, you know, maybe someone can convince me one day. Okay, so flux, solder, or solder, and just gently rubbing. You know, once again, this really isn't me pushing down on that pad, otherwise it would just come straight off. This is me virtually just hovering above it. I'm just letting the actual heat of the solder to do the work, and I'm just trying to get it to push all the gunk away. And then more wick. This is the wick I use, by the way. Just going to flick over to this. It is focus. Oh, I've got to remember the brand name. Good wick. They sell it at my local. They sell it at my little local electronics store that I can actually walk to, which is good because I go through a lot of it. Okie dokie. Let's get that off. And gentle rubbing. Caress it as you would your lover's skin. Okay. Alright. And I'll just scrape that gunk off. I mean, you know, a lot of the recaps I do, I don't have to get the scalpel out at all. But I knew this one was going to be a scalpel-y one. Yes, thank you folks for the likes. I do appreciate it. It really is a lot of repetition. I do apologise for that. So, you know, sort of feel free to ask difficult questions that I can try and answer while I'm doing this. Oh, look at that. Thanks, Steve. Just shared my video link on Twitter. What's Twitter? Only joking. Yeah, so we have a chain of stores here in Australia called JCar Electronics, and they're like Radio Shack. So you can go in there and buy individual components, you know, capacitors and resistors and all that sort of stuff. But they also sell kits and other electronic stuff, you know, and cables and power supplies and all that sort of stuff. So, and as I say, there's one very close to me, and that is a really, really handy thing. Now, I've just run out of my first roll of wick, so I've got a few more. And yeah, so, and they do sell this wick, and they sell solder, and they sell solder suckers like this one here, and they sell them for really cheap too. So, and this is actually one of the things that I do like about this particular solder sucker, and this is particularly a demonstration for Jay, because we have discussed solder suckers before. With this one here, if you fill it up, I'm just going to change over here again. If you fill this one up and you want to empty it, you do it like this. You go twist, open, and then empty it. And then back in, turn, and you're ready for action again. Unlike the other one, the one I had before, which is I think the same one that you have, and it sort of, you have to unscrew the top or unscrew the bottom to take it out. So anyhow, yeah, and this thing really does suck. And it, to some extent, you know, you do have to be careful with it, because this will literally suck pads off a board if you're not too careful. So anyhow, but I like it. Right, so me swapping back to the microscope view, as I am. What am I doing? I'm cleaning this one again. Yeah, you don't want to ever run out of solder. I mean, the thing is, you get caught out when you run out of solder, because you buy these huge rolls and they just go and they go and they go, and then all of a sudden, you know, I mean, I've got a roll of solder here that I bought well over a year ago. This one I've had since I was probably a teenager, but you know, because I don't use that much of this one. But the other one that I have, yeah, it's a huge roll, and it is starting to get a little bit low now, but I've had that for such a long time. But yeah, they just sort of suddenly run out, and it's like, oh my goodness, I need solder. I haven't got them in the description. I should have had all of the buying info in the description, shouldn't I? That'll come later. This one's really bad. This one's particularly scungy, so let's zoom in on how scungy it is. Real crust on this one here. This is, you know, there's copper under there still. I'll get through to it eventually. There we go. Look at that. It's starting to get shiny. Okay. Zoom out. Alright. Doesn't look super focused. Sorry. Okay. Let's get a bit more flux. Don't forget the flux. And some solder. And some wick. And some repetition. Yay. Right. So, the most important tool you can have, a cotton swab or Q-tip or cotton bud, as we call them here in Australia. And the old 99.9% isopropyl alcohol. Okay, I see a great big comment there from Jay. What's he saying now? Pads are much thicker than they seem. Usually corrosion has to be pretty incredibly bad to get the whole pad corroded off. That's very true. Yeah, this is actually, you know, an interesting thing when it really does take a lot for the copper to get corroded all the way through. And this is why when I look at a lot of these, even though they look really bad, I can be fairly sure that they are still making contact. Yep. Okay. I do actually have a board somewhere floating around where the corrosion is so bad that it goes through, and you can actually see how large the groove is from where the copper used to be. Okay, so that is 3 capacitors. My goodness, this could take up to 8 hours. Okay, so this one. I'm not going to worry too much about the heat shield here. I might just plonk one here in front of the RAM. I'll just be careful about how I direct the heat. And I'm going to take this resistor next to it off as well, because that one just looks so scungy. I mean, I should ideally replace it if I can find a replacement. Oh, stick on, come on, let's go. There we go. I mean, look at if you go up here, I mean, look at this gunge under here. I mean, this is just all old electrolyte from the capacitors. Okay, so this guy's already starting to come off. Now, what I might do before he comes off is just scrape a little bit of this corrosion off the top. Let me just get some of this goop off here. I haven't got my air extractor on, but I do have a fan behind me, so I'm blowing the fumes away. 8 hours, get it, Steve? Yeah, I think Steve probably got it. Sorry, Steve. Yeah, I know. It definitely takes longer in the live stream. I accept that. I keep that in mind. So, I'm just gonna check my focus here. Yeah, it looks a little bit better. Maybe. Okay. Just want to try and expose without destroying some of the nice stuff on this resistor, so when I do put it back on, the solder's got something to grab onto. Okay, so here's the fun bit. I want to take this off without losing it. R14 and R15. What are resistors? Are you obviously this one here is actually a 0. That one's actually just a join. So there we go. So he comes off, and then I put him in my special place so I don't lose it. So I've got this little spot over here where I put components I don't want to lose. I'll put components over here that I don't care about, but over here, that's where I put components I don't want to lose. Okay, so I'm going to clean both of these at the same time. So a little bit of flux on there and some some solder. I'm getting fairly familiar with this process now. As scungy as that one looked, it's probably one of the easier ones to clean up because it doesn't seem to have as much of that gunk floating around on, sort of that black crusty stuff on the edge of the pad. So generally with these Mac boards, the way you tell what you're looking at is you got your R for resistors, and you've got your U for your ICs, and you've got C for capacitors. That of course has nothing there, but if it did have something there, it'd be a capacitor. Okay, and gently, ever so gently. There is definitely crust on this, though. I'm going to need to clean that up with the scalpel. Back to the scalpel. Okay. Now, having watched Steve's stream recently, I'll put links to the stream in the description when I'm finished. Or do you not want me to do that, Steve? When you're sort of working like this and you're working with a microscope like this, it makes work so much easier. When you're working with a microscope that is one that sort of projects up onto a screen, you don't get that same feeling of depth, because obviously with this being, sort of, what's the word, binocular, you really do get a sense of depth when you're working there, and you are actually able to do really, really fine work. I mean, unless you've got like real problems with the steady hand. I mean, in theory, you can end up doing much, much finer work than you would think you would potentially be able to do with the power of the microscope, because it just gives you that instant feedback of what's actually going on at that particular moment. So I would sort of say to anyone, if they were wanting to do a lot of this work, the microscope is one of the most important tools, but it is, of course, also one of the more expensive ones. So you've got to be pretty sure about it before you potentially go out and buy one. Oh, thank you, Grudy. Appreciate that. Okay. How many viewers am I up to now? Oh, I'm down to 7, so I got so boring 3 left. I mean, I'm down to... Yes, down to 6, sorry. So 3 left. See, you're all questioning my maths there for a minute. Right, so... Continuing with cleaning. And once again, we've now got some nice shiny pads going on there. So let's just hey Dan. Okay, so that's all nice and clean now. So gonna plonk a new actually I won't put a new capacitor on just yet, but what I will do is I will put that little component back on that I took off. Now there are a couple of ways that you can do this. One way is to put solder onto the pads and then put the component onto that and then use the hot air station to melt the solder and then just have it, you know, sort of land in place. I'm not actually going to do that. I'm going to actually solder it one side at a time for no real reason other than I like to. So this is where I actually pull out the expensive solder, get that tip nice and clean. So I'm using one of these guys to clean the tip, just the little sort of copper meshy ball type thing, and I just stab the soldering iron tip into that, and I just do that fairly regularly, and then it just leaves the tip sort of looking, you know, reasonably shiny. And then I'm going to just get a little bit of solder onto the tip of the iron, and then with the tweezers, my left hand, I'm going to try and hold this into position. This would actually be far better if I turned it around this way. And the reason for that is that I can then hold this like that while I apply solder like that. Oh. Because I've got all of this, what do you call it? Making a right job of that. Because I've got all of this exposed trace there, all of the solder's running down onto that. So I've stuck it on one side. Now we can solder it on the other side. And look, it's not perfect, but I think it's fine. I mean, one way I can test, of course, is to get the old multimeter out and make sure that we've got contact going on there. So I'm going to go stab, stab, and there we go. I'm getting 47 ohms. So that's a good thing. I mean, if it wasn't a 47 ohm resistor, it'd be a bad thing, but it is, so we're fine. Okay, so alright, so that's off and clean. Now this is the little network of horrors up here. So this is it's just I'll do on here. So if we have a look at the board, where I am at the moment is focusing up on this corner here, and that's a sound chip just there, and this is this little collection of really ugly little leaky capacitors. So obviously need to get those off and do it with minimal damage. Okay. Bit of heat. When I'm taking more than one off that are close by, I do them both at the same time, because what happens is the board gets heated up by the hot air station, which then makes the second one come off easier. I said makes the second one come off easier. Thank you. Yeah, there is absolutely nothing good about this section of the board. Okay, so now what we also have up here is plastic, and plastic doesn't like hot air stations. So I'm going to again grab my little heat shield and pop it down this way this time. try and slot it in between. That's a huge one. Let's get a smaller one. Pop that in between the plastic. And there's actually plastic on the bottom of this thing as well, so it's not as crucial, but I still, once again, I don't like sending things back with melt. So let's now try and get this off without melting anything. Stay. Okay, they come off nice and easy. Yes, Steve. Yes, I do sometimes add some flux before I lift them off. I don't think it would do that much with this because there is just so much sort of crust on the outside. So I'm just relying on the heat alone. Once I get them off, I can sort of clean them all up. But yeah, the heat. So I basically, what happens is I heat them up until I see them starting to kind of bubble up. I see the solder starting to get a little bit loose, and then I either just flick them over or pick them up, one of the two. Okay, and I think this is our third last capacitor to remove. And again, sort of the point of this one that I was really trying to make with this board is that this one is in such bad condition that this is one that I really think needs hot air. There are some recaps that I would say, yes, you can do that with just a soldering iron, you can coax those caps off. I know there are people out there that say you can just twist them and pull them off and everything, but we've had discussions about this before, and I don't subscribe to that, especially on a board of this age. If you were to sort of twist and pull these capacitors, you might get lucky. The solder could be so crusty that it'll just snap off without any trouble. But yeah, I mean, there's always that risk that you just tear the pad off with it. So look at this, 0 drop frames. What is this? This is awesome. Do you apply heat to the direct top or the sides? Well, as much as possible, I try and direct it at the sides. If you apply it at the top, the heat will eventually work its way down, but it will take a long time. So yeah, for me, it is basically I just try and aim it sort of at an angle down at the pads themselves from the side. Sometimes you don't have a lot of choice about where you're aiming it because of the position on the board or the heat shield or something, and sometimes I even end up having to move the microscope right out of the way and just point it straight down, because as I say, you're just limited by how things are positioned on the board. Okay, now this is another one that sucks because it's right here next to the SCSI connector excuse me, and it's right next to the battery holder, and so there's just a lot of risk of meltage there. Okay. Yeah, I agree. I cringe when I see people just rip caps off, and I guess the thing that I find most frustrating about it is that when you do it and the cap just comes off, you go, oh look, it was the right thing to do. But the thing is that it's a little bit like playing Russian roulette. I mean, you will sort of, it'll work many times, but then one day it won't, and then you'll be left with a huge job of sort of sorting out how you're going to deal with it. Okay, so this one here, I'm going to probably come at this from, and I may not be able to film this because I do want to come at this at a very much a straight down angle. So for this one, I'm going to change to this view, because then you can at least see me kind of pointing this straight down. And I should also mention that these do blow up sometimes, and given the fact that I haven't got my eyes over the microscope, I'm hoping this isn't one of those. So I'm just basically putting the heat straight down on the cap. That does look like it's going to pop too. It's going to blow! And I'm just, what I do is that while I've got the heat on it, I just nudge it with the tweezers until I feel it give, and which is what just happened. So I sort of just, I just sort of nudge it like this while I'm applying heat to it, and then you just sort of feel it give and it just pops off. Okay, so that's one out, and I can smell fish, but I can't smell burning plastic, so that's good. And then the very last one is up here by the SCSI port. So once again, surrounded by plastic. Look at that. That is a fuse, and that is not meant to look like that. That is meant to be kind of shiny, and it's like, it is just really, really scungy. Now, I'm pretty sure it will still be doing its job as a fuse. I'll just check that now. Oh, God, look at this scunge. Come on. I'm having so much trouble getting through all this junk. Come on. There we go. Okay. So, there is still power getting through that fuse. But yeah, that don't look good. And I mean, look at this guy. Look at him. I mean, yeah, not ideal. I may have to, once I put this through the ultrasonic cleaner, I may have to come back and you know, go over some of this stuff, because some of these might need to be taken off. If I see really bad looking joints, I will take the component off, clean the pads up and put it back again. Alright, so our last capacitor, and it's a 40. You know, can I tell you something that's a little bit amusing? I still haven't done my cheat sheet for this one. Here I am lifting off all these pads and I haven't done my cheat sheet yet. Good job I've got a photo of what it looks like. Okay. When I refer to my cheat sheet, I am of course talking about my little capacitor replacement guides that I create that have little photos of the caps and their ratings, their capacitance rating and their voltage rating. Alright, that is all of the capacitors off. And so now it's just down to the cleaning. So these are the ones that, as I've said before, these ones are, you know, they're tiny, they're all grouped together, they're a bit of a pain, so I'm going to do these ones first. Losing stuff. Flux. Solder. There we go. Yeah, they're actually coming up quite well. Quite neat and tidy. And my wick, which obviously if you've never used wick before, you have to cut the used bits of it off on a regular basis. And okay, looking pretty good. And whole viewers. Okay, what did you miss? That's a good question. What did Jay miss? I'm not sure. I wasn't paying attention. We talked about just how scungy this board is. Oh yeah, there was a great big spider as well. Okay. Right. And these ones. Now, one of the things that does suck about these smaller capacitors is the tantalum replacements are virtually the same width as these pads. So they are a little bit tricky to put on, but by no means impossible. This one needs some trimming. It needs some trimming. Okay. Right. Oh, bit of scans there. It's got to be clean. I mean, as I mentioned in one of my other videos, with these, most of these are other people's boards. They're not my own, so I do have to be diligent. Is it just me, or does that look out of focus? Ah, it's better. Okay. Okay. Right, it's looking good. I mean, when I say looking good, it's all relative, isn't it? I mean, it doesn't. It looks awful, but, you know, it's getting better. There we go. And I have mentioned this before in my videos, but I'm just going to make mention of it again here, just in case there's anyone who hasn't watched my videos. For my soldering tips, I use beveled edge tips like this. So they basically have one flat area on them. The main reason I use them is because when it comes to applying heat to something, you know, using a soldering iron to apply heat, you're wanting to try and get as much surface area onto whatever it is you are heating. And so, you know, you really want to be able to get that flat surface on there. So it's the same as I use little kind of wedgy ones like this, and they've got these flat surfaces on them there as well, and you can use those. The worst kind of tip that you can use, again, this is my opinion, but you know, that's what I would say, is a conical tip, one that just has a fine point on the end, because there's this sort of thought that you'll just go point it at something and then, you know, you'll melt the solder. It's really not that simple. I mean, you need to have some flat surface. And even these ones here, a lot of people use these. These are a nice compromise. They are like a conical tip, but they're bent, so you can actually hold them down on the board and get some more flat area, more, you know, sort of heat onto the board. But I have been using these sort of these little beveled edge ones now for such a long time that, you know, I just love them. And then I've got a really thin little beveled edge one. I've got a great big fat beveled edge one, and I just grab the size one that I need for the work that I'm doing. So, and they're the main ones I use. So I mainly only use 3 tips. I do have lots of other ones, and I do occasionally use them, different ones for different things. But for the most part, it's just those beveled tips that I use. Right. Oh god, it's bloody out of focus again. Or still, depending on how you want to look at it. Right. How are we doing here? We're 11. Oh, just dropped down to 10 viewers. But I do thank you for the people that are watching, and I thank you for hanging on and sticking with this, which I totally understand could be unbelievably boring. When I'm putting sort of new capacitors on, I'm always looking out for areas like this, where a little bit of copper has come away. And the reason is that when I put my new cap on, I don't want something to accidentally touch that. It's not meant to. Obviously, you can see that that one goes to there, and this one goes to down here, and then this little piece of copper in the middle here has nothing to do with either of those. So if for some reason, you know, a bit of solder or whatever were to hit onto that, I could go in and accidentally create a short. What's the tips on your other videos? I'm guessing yes. I have a link to the main tip that I use. Keeping in mind that these are T12 tips. So these are the tips that go with a few of the Hakko soldering irons. And for anyone out there that can't afford a Hakko, there are actually some half-decent rip-offs out there. I've actually got one over there. And they take the Hakko tips, and they take the rip-off tips as well, for that matter. The thing I really like about these, the really important thing about them, is the fact that if you're in the middle of soldering and you decide you want to change the tip, you can just do this. And that is piping hot up at the end here, but it's cool to the touch down the bottom. And so I can then swap a tip over and put another one in, and then pop this back into the little holder and into there, and we're away. So that is an incredibly convenient thing. I mean, that is just so quick and easy to do. So so anyhow, that's here. But I will actually add links after I've done this to the tip. But as I say, that's the main tip I use, and it's a beauty. Okay. Right. Okay. Now, right. So, oh yes, I've got one more little cleaning job to do, and this one is nestled in amongst all this plastic. So I have to come at this very carefully because I don't want to melt anything. And when you're looking through the microscope, it's actually really easy to sort of not be aware of what's going on around you and melt something by accident. Okay, so I'm just checking the angle that I'm coming in at here. Make sure that I'm not going to melt some plastic. Because despite evidence to the contrary at the beginning of this stream, I very rarely melt plastic on the boards I work on. Okay. And more wick. And oh, that's time for trimming. There's a black splodge. Don't you hate those splodges? I'm going to scrape that splodge off. That splodge has no place here. Oh God, I'll tell you what, the number of times I lose my scalpel. Anyone see where I put it? Can't be too far away, I haven't moved. Oh, I bet you I dropped it. Drop everything else from here. Nope. 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 Oh, here it is, it's hiding under the flux. Alright, so just here there's a little black dot on there, and I just want to scrape that off. There we go. Oh. Just melted some more plastic. I don't think you'll see that one though. You just hear a sort of slight bubbling sound, and then you just smell plastic and you think, yep, I just did it. Again. Okay. I found it. Alright, so. While still trying to remain as professional as possible. Clean that one off. And I think that's your lot. Yep, they're all of the pads are now clean. So it's time now for putting new caps on. So I need to grab one of my photos of this board, which I didn't bring down with me. Isn't that cool? And oops, so that I know which ones to put on where. So we have, zooming in, we've got 10 microfarad 16. So obviously anyone who's doing recapping on these Macs, there are pretty much 4 different types that are used on most of these old Mac boards, and they are the 47 microfarad 16 volt. This one has 5 of those, so I'm just going to grab 5 of those now. 2, 3, 4, 5. So that's my 5 47s. The other size is 10 microfarad 16 volt. And this one has 4 of those. 1, 2, 3, 4. And yeah, those traces do look damaged. Look, I actually think those traces are still carrying electricity, but this one in particular, and those two there. If I give that a bit of a scrape, you'll see we've still got copper under there. So that one is still making contact, but yeah, these are the ones that need to be sort of cleaned up. Where's the Go Fast juice? It's 3 o'clock in the afternoon here, and it is a work day, and so in the interest of professionalism and the fact that I do need to actually drive a car later on, the Go Faster juice might have to wait for maybe a late night live stream sometime. And I'll do that when it's one of my own boards and not a customer's board, for obvious reasons. I can just sort of see a situation where the customer sees the live stream and says, you know, I don't want to pay for that because you were drunk when you did it. Okay, so this is just hanging on by a thread that has eaten through. Now, if I put a multimeter on that, it's probably still making contact, but obviously the clever thing to do would be to do a trace repair on that one, which is what I'm going to do, because I like to think that from time to time I am clever. Not always, but from time to time. So I would say I'll be inclined to repair, put a bit of wire on this one, and this one. So this is a board full of adventure. Oh, this one's not too good. Oh no, that's okay. There's copper there. There's copper there. There's copper there. All these ones that I'm scraping off, when they all get cleaned up, I then paint UV solder mask on top of them. Had some excuse juice. Yeah, well, I'm not saying that I can't recap with that, but yeah, it is the middle of the day here. I mean, what would people say about me if I started drinking now? They might start to know the truth. Okay, so I'll do this one firstly, and this is always fun. So first thing I do is get solder onto the little exposed bits of copper. And the way I would normally do that is just, oh God, look at this gun. I'm bringing fluff. Goodbye, fluff. You have no place on this board. Why not just solder blob it? Yeah. Look, if I can put solder on it and it looks like it's healed, I'm quite happy to leave it. But if it's sort of, I mean, it is hard to try and get a blob to stay on there, to be honest, without at least something there to hold on to it. And then I'll get my wick and I'll just rub these a little bit clean. So, yeah, I mean, of those ones, this one, maybe pointing, this one down, oh God, still fluff is still stuck there. Still got fluff. This one here, stab it, there we go. This one here is, I think is fine. That one there I want to put a wire on. That one there I want to put a wire on. And that one there I want to put a wire on. It doesn't need to be anything particularly extravagant. Will I use my really thin wire? Because, yeah, I think I use the mid-size wire. I think it'll just be easier to manage. So this is the wire I'm using, which is 34 AWG. And that's American wire gauge or something like that. And it's the enameled wire, like transformer wire, and so it's obviously the first. Oh God, I just found another one. Piffle, look, everywhere. They're everywhere. Right, okay. Yeah, there we go. Right. So let's start from here then, shall we? Get my little bit of wire and a little bit of flux. The flux, another really handy thing about flux is that it helps hold things in place. So I will then get some solder onto my soldering iron tip, just a little bit, don't want too much. And then I'm going to put this here, try and hold it in place. And in the right place. Come on, up you come. There we go. Holding the iron on it to melt the coating off this wire. I don't have enough flux here at the moment. The solder is just staying on my iron. It's not actually transferring. So this is when we start getting angry with the flux. And look, I mean, what is that? Is that a hair? Okay, so then let's just hold this in place with the tweezers. And there we go. And that is one wee little repair trace. So just very gently snip that off. Use it for the next one. Yeah, I think there is a spider tossing fluff around here somewhere. Right. Another one. And solder onto the end of the tip. And begin. Hey, how about that? We keep it like that? I like it. It's creative. Okay, just going to trim that off. Trim it off a little bit further. There we go. Off he comes. And then, needless to say, I'm going to put some flux on there and I'm going to resolve this issue. Like that. Okay. And there was one more, wasn't there? And I managed to build up quite a bit of... Looks like, oh, there's another one. I want to stop finding these. You know what? I'm going to come back to those. You know why? Because there are going to be so many on this board. It is just going to get so boring. Yeah, see that little blob of solder there. That was an Apple mod. You know, you could do that and it would speed the computer up. These are the sorts of repairs I really wouldn't recommend doing without a microscope, only because being able to see the solder really closely just makes it so much easier to work with. Now at some point I'm going to have to just say, you know what? That's enough trace repairs for today. Right. Now, what was I doing? Putting capacitors on this thing. Far out. I mean, it'll still work. It'll still work with those like that. Trust me. Maybe. And we know these are pretty resilient machines, don't we, Steve? Oh, actually, he's gone. Okay. Right. Alright. So, I was working my way through the capacitors, wasn't I? And then, so there was the 47 microfarad 16 volt, 10 microfarad 16 volt, and then 100 microfarad 6.3 volt. That's there's only one of those on this board, but that's another fairly common Mac size. And then the other one is 1 microfarad 50 volt, which I'm running a bit low on, but thankfully most of the time those 1 microfarad 50s are, there's usually only one of them on the board. So I mean, I've got, all right, 1, 2, 3, 4, 5, 6, 7, 7 left, so it's theoretically 7 boards. I have an old 80s Seiko watch I fixed, needed a microscope, but instead used my iPhone on magnifier assisted access mode. Worked really well for that one job. Well, yours must be way better than my iPhone camera, because I'll tell you what, that certainly wouldn't work on mine. I mean, having said that, mine is an iPhone 7, but you know. Okay. Right, so let's start up in the corner here. And these are all of them 10 microfarad. So these are the smaller ones. How many did I say there were? There's 5 of those, I think, yeah. So these are the smaller ones. But if I plonk them in place, you will see that they are about the same size as these pads here. So there's very little room on either side to get any solder on. I realise it's on backwards. I'll resolve that in a second. So yeah, that's just one of the tricky things about working with these ones. Sorry, I just got to move the microscope. Sorry about that. I just am making things very difficult for myself here. Okay, so I'll start with these two because they are facing in the right direction. So they're both of them positive facing to the left, and as I have mentioned in my videos before, if you are working with electrolytic capacitors, there is a stripe on the negative side. If you're working with tantalum capacitors, there is a stripe on the positive side. That's because someone out there, I think it must be some sort of, you know, mean, nasty person that's decided to make it confusing for beginners. Okay. I have a 475 that needs doing. I will watch the vid again while doing it. Keep up the quality vids. Thank you very much. Now, I actually have right here a 475 board, and the one really good thing about this one, first of all, there are a lot, actually no, there are heaps of caps on it. What am I saying? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 caps on it. 10. I just found a hidden one there. Oh, 11. There are 11 caps on this board. But thankfully, because they're a little bit newer, they probably won't be as crusty as this one. So you probably won't have as much trouble getting the caps off it and cleaning up the pads. So, right. Where was I? I was putting that there. Right. Now, this is the bit. This is the bit that I always sort of talk about. This is the way I do it. It's not necessarily the way other people do it. What you can do is you can put solder onto the pads, and then you can kind of melt them on there. Now, I choose not to do that, mainly because you melt one side, the capacitor comes down flat with the board, and then when you go to do the other side, you know, you end up with the capacitor sort of a little bit, you know, wonky. It's not flat on the board. When I do it this way, I can actually hold the capacitor nice and flat to the board. So I just get a little bit of solder onto the tip. Now, I've said in my Learn to Solder video, if anyone has been patient enough to watch that one, that the solder, when you buy it, has flux running through the middle of it. And the idea of that flux is that at the point you melt the solder, the flux helps the solder flow and stick to whatever you want it to stick to. Now, I'm going against that by putting the solder onto my soldering iron tip first, because what that then means is that flux in my solder has done nothing. It's given up its life for no purpose, because this is now sitting on the tip of my soldering iron, and the flux is not doing its job anymore, because this is now oxidizing as we speak. That's why I have copious amounts of flux on the component, because that's then going to help the solder flow off the iron and onto the component. So it's all about the flux. Right, so this one I've got to hold it at a kind of weird angle, because I've got masses of plastic over here that I do not want to melt. So I'm going to just come in at this at an angle like that. I'm going to hold this in position as centered as I possibly can, and holding it. So I want to still have a little bit of pad on the other side. I'm going to just apply that there. And you kind of feel it. There's a point where when you're melting it, you can kind of feel that solder has actually gone onto both the pad and the component. And then I hold it down with the tweezers. You can actually see it bending up and down there. It's sort of springing on the pin of the capacitor there. But I generally then hold it down with the tweezers and I just rub it like that, just sort of to make sure that it's all neat and tidy. It's a good looking joint and all that sort of stuff. Okay, so that's stuck on. I know that's stuck on because I can give it a nudge and you can see that one side is on and the other side isn't. And then we'll move on to this one. Now, another thing that I've said is always do the easy side first. And with this one, the easy sides are this one here and this one here, because these two are in, there's not a lot of room inside there. So I'm going to leave those middle ones to last. So again, I need to spin this around. So I'm a right-hander, so I need to come at this angle. I will get some solder onto the soldering iron tip. And my God, I've been going for over an hour. Sorry, everyone. Be careful what you wish for, AJ. And then, sorry, it's out of focus here because I'm with the microscope. Just pushing down on the board is enough to make it go out of focus. So, going to just do this as quickly as I can. Hold that in position, and there we go. A little bit crooked. Hold it down. There we go. Okay, so that one's stuck on that side, and this one's stuck on the other side. So now I can just come at it from the middle, and it'll be a lot easier because I don't need to worry about that component moving around or anything like that. So I can just come in like that. Doesn't fit. This is one of these times where I go and get a different size pin. A lot more fun than a Rossmann vid. That's very good to hear. Do you want me to start saying political things? Stuff it. Where is that? That goes there. You can stay over there. Just going to grab another pin. Thank you, Jay. I appreciate that. Okay, so this is my little tiny beveled edge tip. As you can, still a beveled edge, but it's very, very thin. So I still have that flat surface area to work with. When I'm working with my my modern Macs, that's not a good example. That's not particularly modern at all. But I'm sure I've got one here somewhere. Modern-ish. When I'm working with my modern-ish Macs, if you have a look at these under the microscope, hey, now it is starting to look like a Rossmann vid. Hey, as you can see, I mean, these are a lot smaller, so you need to work with a much smaller, sort of tip for those, for the most part. And so this little tip is the one that I would use typically if I'm working on a modern Mac. But in this instance, this is what I need for squeezing into a little thin spot. Now, I get asked all the time what temperature do I have my soldering iron on? And one of the things that I sort of say all the time is that I do actually run my soldering iron very hot, and it isn't necessarily a temperature that I would recommend to everyone, because I tend to sort of get in and out very quickly with the soldering iron. So I just, I work at like sort of about 430 degrees C, and that I would probably say is a little bit hot for a beginner. So anyone who's starting out, probably go with a lower temp than that, maybe high 300s or 400 or something like that. But oh, what have we got? Love chatting about Mopars. Okay, well, I can talk about Mopars. I can talk about the fact that mine's been in the shop for probably nearly a year now. I'm not thrilled about it. I mean, it's largely my fault, but you know. Okay, so right, so that's now got solder on it. I'm just going to push that down to make sure it's flat. Do the same to this side. And the same that side. So now I can see that both are stuck down good and solid. Would running the board through an ultrasonic before working on it have benefits, or does the fluff and electrolyte on the board help diagnose what's wrong? Definitely. If there is a fault on the board, sort of seeing some of the areas of corrosion can definitely help, because you can look at a particular IC and think, that one is potentially going to have some problems. One of the main reasons why I clean second and, sort of do the work first and clean second is the fact that I get all of this gunky residue all over the board when I'm doing the recapping. So I generally save the cleaning for when the job is over. But having said that, a board like this, probably not a bad idea to clean it first, because I suspect that after I clean this, it might actually show me some more problems that need to be worked on. But that's just part of the fun, isn't it? So, all right, 2 more little ones here. Let's see if we can knock this over. Okay, and I might leave my small soldering iron tip on just for the moment. Seeing as these ones are ones that are cramped as well. So these are the same little guys. These are the what did I say? I said 10 microfarad 16 volt. If anyone's actually wanting to kind of decode what's written on these, you can see that says like 106C on this one. No, you probably can't see that because it's upside down. This says 106C. Now, this is where I always forget, and I always end up having to look these things up. So the idea is 10, that's what you're starting with, and then 6 is the number of zeros after it. So it's 10, or it's 1 with 7 zeros after it. 10, 0, 0, 0, 0. So, or 10 with 6 zeros after it. And that then tells you, I think that's in, is it in picofarads? I think, something like that. I can't remember exactly. That's the sort of stuff that just sort of leaks out of my brain, but that's how you kind of decode them. You know how many microfarads they are. So, I like that. Pre-cleaning is like the fire brigade's ashing off a crime scene. Erase all the evidence. Yeah, it is. Yeah, it is very true. I mean, with this one, these ones, it's probably less of an issue because we're not necessarily talking about ones that have had water damage and you're looking out for that sort of stuff. But it definitely does help a lot of the time where you can see, I mean, most of the time with these ones, it's just around the capacitors. Well, the problem's always going to be around the capacitors. Okay, once again, starting with the easy side first. Yui. Okay, let's hold it down, and again, there we go. And I have a garage full of Fords and vintage computers, mainly Macs. Yeah, well, I can't say anything too nice about Fords because I am a Mopar person, but I will say I do like the idea of cars and Macs in the garage. If I say nice stuff about Fords, I'll get disowned. But don't take it personally, please. I'm just grabbing this and having a look underneath because I just want to make sure that these areas here have still got good coating on them. Because as you can see, this is wider than the original capacitor. So this metal part has the potential of, sort of coming in contact with this here and here. Now if that coating was exposed, I could accidentally create a short, so I don't want to do that. Okay, let's see if we can get that to stick. There we go. Okay, doing the PowerPC challenge. It frightens me. It frightens me, the old PowerPC challenge. especially after using my little Mini for a while. One of the things that I've found in using an old power PC a fair bit lately is one of the things that I struggle with is the loss of all those kind of cloud services, whether it be sort of calendars or messages or sort of even notes. I mean, I use the iCloud notes all the time. I put a shopping list on my sort of on my phone, and then I can check it on the computer and all that sort of stuff. And you sit in front of a power PC, and all of a sudden, all of that sort of all of that cloud stuff is just gone. And that is something that I definitely struggle with. But I still love it as a concept, and I am going to do my best. So we've got one more of our little guys, just ahoya, where I had that capacitor, that resistor that I removed and put back, and I have lost one of my capacitors. So apparently tantalum, which is obviously what they use in these tantalum capacitors, is quite a rare metal that they have to mine, and it's apparently about as common as uranium, something that I read. And so there is always that danger that one day we won't have any tantalum capacitors because we'll have run out of tantalum. Okay, yeah, I better give someone some mod, hadn't I? Here, I'm gonna mod some people that that know how to mod. Add moderator. Add moderator. And where'd Steve go? Oh, never mind. I think he's too far up in the chat. Okay, so. Okay, feel free to paste that link now. Jay, you have the power. As long as it's not like something, weird. Oh, what flux do I use? I use Amtech NC559-V2TF. And so anyone who ever watches the old... oh yeah, there's the PowerPC channel link, yes. So anyone who ever watches any of the old Rossmann vids, this is the one that he uses. And I got the recommendation from him. So, and it is a good flux. It works incredibly well. I have found ones as good, but interestingly enough, the main reason why I use this one over some of the others is some of the others really stink. And this one doesn't smell too bad. So... it's a small thing, but if you're working with it a lot, and you do get wafts of it up your nose every now and again, though you do try and avoid that, at least it's not too offensive smelling. I got another Amtech one that got sent to me for free. And when I bought some, they said, "Oh, this is the new one, the next generation," and it was nowhere near as good. I didn't like it at all. Apart from everything else, it was opaque. And I hate not being able to see through the flux. I mean, I know it's not completely see-through, but I think it's going to be time for me to change back to my other tips soon. What do you reckon? This one here is starting to piss me off. Bans Bruce from his own stream. Better not. You could, though, because I've got absolutely no idea how I would change that. Because just a reminder, this is my very first stream. Right. How do I feel about using expired flux? I feel good about it. I have never, ever had any issue with expired flux. I'm not saying that I want to actively seek expired flux, but I have used it before, and I've really never had any issue with it at all. It's still very fluxy. So, yeah, no issue with that at all. One of the things that I have found you do want to have reasonably sort of new is solder paste. I find that stuff gets a bit funky when it gets old, but I don't use that very often. I only use that when I'm doing reballing of BGA chips, which of course is one of my least favourite jobs in the world. But, you know, it has to be done from time to time. For your first stream, you're nailing it, Bruce. Thank you, thank you, thank you. I appreciate that. Thank you. I probably should have done this one really, really crappy, shouldn't I? So then, you know, I could gradually get better. See, if I do the next one, everyone's going to be expecting, you know, greater things. Now, here's a really interesting specimen that you do find from time to time, and it's one that I forgot to clean before. So we're going to do that now. It's the sort of mistake you would expect from someone like me. Okay. Well, thank you for the compliments, folks. I do appreciate that. It's you do have to, when you're doing something like this, you do have to sort of say to yourself, who on earth would want to watch this? But you know, if people are enjoying it, then I'm happy. Okay, so investigates my Macs with modern SMD electrolytics. My understanding is the modern caps are supposed to be less likely to fail. I can't help but want to replace with the like. That's a really interesting point. Captain 318. Is that like a reference to a Mopar engine? As in like a 318 small block? Anyhow, the thing about electrolytic caps is that they have liquid electrolyte in them, and that is pretty much unavoidable. All electrolytic caps have an expiry date. Ultimately, they will eventually dry out when the electrolyte sort of dries out. And one of the things that heavily influences the lifetime is the heat that they are run at. And the lifespan that capacitors have is based on them running at full temperature. So if you go and buy some capacitors, they'll say it's got a 1,000-hour lifespan, and that doesn't mean the capacitor's only going to work for 1,000 hours. But what it means is that running at its maximum temperature, and with a lot of these it's like about 85 degrees C or 105 degrees C, depending on that rating is usually on them somewhere. And if they are running at that top temp, so they're running at their kind of, you know, their maximum spec, they will you know, sort of degrade after 1,000 hours of operation for one that has a 1,000-hour lifespan. Now, keeping in mind that there are outside influences as well. Heat doesn't necessarily just have to be generated by the capacitor. For instance, if you're using a capacitor, say in a power supply, it might sit right next to a great big heatsink, and that heatsink might be spitting out all sorts of heat, and that capacitor can end up dying quicker because of the heat that it's exposed to in its lifespan. So this is a very, very long answer to a very short question. I do apologise, but basically the thing is that yes, electrolytic capacitors do have a limited lifespan. So when you put new ones on, you know that they will eventually die. But yes, the other thing is that they are getting better at them these days, and you can buy good quality ones that have quite long lifespans. You might have to pay a little bit more, but you know, you can go out and get a good quality brand that, you know, is rated for 2,000, 3,000, 5,000 hours, and you can put that on and you can say, look, there's a fairly good chance that they'll never need to be changed again. Particularly as these days, these things aren't being used as people's daily drivers, you know, they're not being used as their main computer. People are just firing them up, playing a few games and sticking them back in the cupboard. So, you know, you'll probably find that those capacitors will, you know, you won't need to worry about changing them ever again. So, there we go. There is a very, very long answer that you didn't actually ask for, but never mind. Okay, so righty. Quality of your micro camera sucks though. Just saying, mine is way better. Yeah, I know, I've heard that about your microscope, Jay. Right. Okay, so now I've done all of the little ones. So now we've got, there's one more, which is this one here, I think. Let me just check. 107, that's it. So this one here is a 100 microfarad and 6.3 volts, and that one lives right up here. So here's where our little cluster of 4 are, and then just below it there's that one there. Now this is the one that I had some concerns about with this being exposed. Now there isn't really anything I can do without in a live stream about that, because what I would typically do with that is I would paint a little bit of UV solder mask on that, and I can't really do that because I don't have enough time to dry it. So I use this here, which is a UV lamp, and if I just switch this on, so that's like a black light, so we can go out and party and go to discos and stuff like that and wear some fluoro makeup and stuff. So there's that, and I use that to dry the UV solder mask, but even with that it does take several minutes to do, and so I'm just going to make sure with this that this isn't going to make contact, and I don't believe it will. If we look at this, twist him on his side, you can see that when I put that in, those pins, the solder, they're not going to be anywhere near that little exposed bit of trace. So I'm quite comfortable with that one. That will be okay. I'm just going to spin him around, and then I'm going to get some flux on there. Interesting thing, and people may or may not be aware of this, this is just a little tip that is completely unrelated to what I'm doing. But I had to do work on a mouse the other day, and I had to replace the little infrared transmitters that shine through the little decoder thingy for the mouse to work. Now, I won't go into the finer details of how a mouse works, but anyhow, it had an infrared transmitter, a little emitter on it. And you can't see infrared because it's outside of our visual spectrum. But CCDs, CCD to charge coupled devices, the little things in all of the digital cameras we use, whether it be this microscope camera or whether it be a webcam, or all of them use CCD cameras in them. CCDs pick up infrared. So if you're ever wanting to test an infrared LED or an infrared light or anything like that, even the remote control of your TV, if you shine it at like your phone camera or your web camera or whatever, you can actually see the light come on. So for anyone who didn't know that, you probably did, but if you didn't, now you do. Okay. Right. Where are we? Here we are. Camera and not all. It's nerd therapy, very relaxing. Yeah, well, can't help. We're all nerds, aren't we? If we're watching this, we probably are. Okay, just making sure that I'm not missing anything here. Right, okay. Is everything still working? Just check and make sure that everything's still working. Appears to be. Good. Right, let's get another capacitor on here because, come on, it's getting late. I'm sure it's getting late over there, and people are going to want to go to bed, and, I know how awful it is to, have to miss out on the ending of something. So, keep ploughing through this. There we go. As I've probably just demonstrated then, how much easier it is to put these big caps on. Try it on some newer iPhone cameras. It doesn't. Try it on some newer iPhone cameras. It doesn't work. Well, that's shocking. I'm very disappointed to hear that. That's oh well. It certainly works on this microscope camera, I can tell you that much. Right. So the last of all are our 47 microfarad capacitors. I'm going to start here with this one that's crammed into all this plastic. I'll get it out of the way. Make me feel better. Flux. Capacitor. There we go. And so Same as before, easy side first, which is going to be this one. Actually, I might have to come at that angle so I can hold it like that. Well. See, it keeps ending up crooked. It's not good enough. It's just not good enough. Come on. Okay, that'll do. Now this one, I think I just have to think about it. Yeah, okay. This one is going to be a without microscope solder, and I apologise for that, but I have to come at this straight from the top down. So just moving the camera away, let me sort of give you something exciting to look at. So there we go, just gotta, look at that. Cut copper only. There we go. Right. And then I'm just gonna poke this down the top. And let's see if I got that. Yay! Join! And no melted plastic. Today is a good day. It's just 11:45 p.m. yesterday our time, so well, that's good to know. So yeah, I mean, I'd be in bed by now if it was me, but you know. Right, we're going to do this one next. This one's up near the SCSI port. Ba-ba-bam. Okay, so capacitor, and I do apologise for all the board spinning. I know it's sort of probably give you all motion sickness, but it's just the nature of the beast. The LCIII is one of the computers that didn't come with a 68882 FPU math coprocessor, also referred to as a floating point unit, called a floating point unit because it is involved in calculating excuse me, decimal numbers, non-integer numbers, great big long numbers. And this this one didn't have one, but it did come with a socket. So when you bought it, you could have a look at that empty socket and pine for a coprocessor to fall out of the sky and land in the socket. Of course, anyone who is collecting these, if you jump onto eBay and do a search for 68882, you'll find that they're incredibly cheap to buy these days. So there is absolutely no reason why any vintage Mac collector should have an empty socket on their computer. Go and fill it up with a 68882. Alright, so there's that one, round the right way, joined, yep, happy joy. That only leaves us with 3 left. It's nearly over. Oh no. Okay, so which way do you think I'm going to stick C22 on? Are we going to stick it around the way that says on the screen printing? Or am I going to stick it the other way around? Well, it's a very good question, Captain 318, about the whole math coprocessor. I'll tell you what it does do. It allows you to get good scores when you run speedometer and it does an FPU test. And you can go, wow, look what that FPU did. It got me scores on speedometer's FPU test. That's about it. I'm sure there are certain tasks that it helps with. I mean, you know, I don't know what they are, but I'm sure it does. You know, for when you're, I don't know, doing an unsharp mask in Photoshop on your Macintosh LCIII. Yeah, I'm not really sure. Look, I'm sure there are certain tasks where a math coprocessor will help, but yeah, who knows. Still worth putting one on because they're so cheap. So, do you want me to put, okay, upside down as well for C22, do you reckon? Okay, so where are we? Going to grab some solder here. Now, how's my room there? I don't like the amount of space I have on that side, so I'm not going to do that side first. Let's do C22. Kill the anticipation. See the fact that I've actually put it on the way it's silk screened. Okay. You watch. Someone's going to watch this video and go, "Hey, you've put that capacitor on the wrong way." People like you. Okay. Now, see, the OCD in me is really upset about the way this one is not in a straight line with the one below. Yep. Nice big blob there. There we go. Okay. I mostly use my Mac Classic Macs to run educational software that we ran in my elementary school, like Mouse Practice and Super Munchers. Yeah, I mean, it is amazing the nostalgia that that you get with these. I mean, I know that whenever I get a new vintage Mac, I mean, one of the first things I do is fire up Sid Meier's Civilization, because it's a game that I used to play on them quite a bit. And of course, it is also a game that even today, I mean, you can just start playing a game and get totally hooked. And so for me, it's sort of this one I'm going to have to come it from the top. Well, actually, I'll tell you what, I'll come it from the bottom. I'm going to do it that way. I mean, I think this is one of the things that has just made this, people collecting these Macs so prevalent, and that is that, people grew up with particular software or particular computers, particular Macs, and they've just sort of said, I remember that game. That was awesome. I want to play that again. And so they grab the old Macs and fire up these old games, which of course are so readily available these days. Right, now this one, I'm going to need my thin tip for again. Grabbing that now. This is the last join of the last capacitor on this board. An auspicious moment. Just waiting for the soldering iron to heat up. This iron does heat up quite quickly, by the way. It takes, I don't know, about 10 seconds, something like that. Right. A little bit of solder on the tip there. Sneak that in there. My tip's a little bit bent, you might notice. Now, this is an interesting thing. I'm having a lot of trouble getting enough heat. As I put this here, the solder is actually cooling while I've got the tip there. And that is basically because, you can see all of this copper along here. That's sucking all the heat out. Because obviously copper is just making all that heat dissipate. So that's the problem I sort of have with this one here. But that's an okay joint. I'm fine with that. Ouch. Tip is still hot. Now, so this is all awful, but it has now been recapped. So the first thing I do, as I've often mentioned in my videos, is I check to make sure that I've put everything in the right place. So with this one we have was it 5? Oh, okay. That was 9 minutes ago. Okay, someone is coming here to pick up a repair, so I may have to disappear when that happens. That was 10 minutes ago. So, okay. So I've got my basically my 5. Let me just go back to the little picture I had on here. So I've got my 5. 10 4 10 microfarad 16 volt. Hey? 5. 1, 2, 3, 4, 5. Yep. 5 10 microfarad 16 volt. So there's one. So with these I always check to make sure I've got the right one on there. I check to make sure that it's the right polarity, and I check to make sure that it is stuck on both sides. So this is me just working my way through. There's that one, that one, that one, that one. They're all got the positives there. That one, that one, that one, that one. Both have positives pointing to the top. Then we've got our one little 100 microfarad 6.3 volt here. That's there, positive at the top. That's stuck on. We've got a 47 here, positive, stuck on. We've got a 47 down here. There's the positive, stuck on. Oh, he's at the front door. All right. You'll excuse me, folks, while I go and undo this. I really didn't want to stop the stream part way through, but I may not have an option. So I'm just going to do this, and I'll go. Oh no, that'll take me too long. So just bear with me a moment. I'll be right back. I'm back, but I'm not really back. Searching for something. Ah, there it is. Found it. Everything's fine. Back soon. Ha! Right, I'm back. So that's all of the capacitors in place. So I guess I kind of need to test it, don't I? I mean, do people want me to test it, or we just accept that it's recapped and done? I'll let the masses decide. Have they seen enough? Should I just sign off? I did this with normal latency, not ultra low latency, so the latency is forever. Okay, you can all come back now. Test it. Oh, okay. Why? We don't get to experience the ultrasonic. Well, we can definitely experience the ultrasonic, but then I have to wash it and dry it, and that takes time. So, all right, okay. The masters have spoken. It's got to be tested. Now, I am just going to need to pop up and grab a case, and then I will test it. Now, the one thing I don't have down here is a display. So I'm afraid the extent of the testing will have to be a chime, rather disappointingly. That is something I will have to rectify in the future. I'll have to get a screen or something here that I can set up, but I do most of my testing up in the house, which of course is not where I have all of this stuff. So, but I can at least connect up a speaker and a power supply, and we can fire it up and see if it bongs. Be right back. Now, this is my LC2, which obviously is not an LC3, but all of the important stuff is the same. So I'm going to whip out the power supply. This is one that I kind of rescued. This one was really badly covered in corrosion, which is why it sort of looks discoloured, because I had to scrape all of the rust off, and then I painted it with a like a rust killer stuff so it doesn't get any worse, and of course recapped it because the caps were all a mess inside as well. So there is power supply, and for those who aren't aware, same power supply, LC, LC2, LC3, LC475, same power supply for all of them, so very handy. Then I have, may as well connect up a fan here. Connect that up. Why not? Okay, it's a shame that the camera doesn't show this, so I can just sort of maybe shine this down. Does it go any further down? Yeah, it does. Right. Okay, you can see my fat gut too. Right, so let's go to big picture. So, we've got that's our computer there, we've got our power supply, and he is going to connect up like that. And then I'll get the speaker, and I'll connect the speaker up as well. Wrong way, right, no, that's the right way around. There we go. So, got my little speaker, got my little fan, got my little power supply, and to my US friends, look at our wacky power cables. Look at them. Look at them. But of course, that end is the same. There we go. There we go. Right. Connect it. Now I'm going to get the old microphone here. Testing, 1, 2, 3. And I'm going to put this right near the speaker here, and we're going to keep our fingers crossed and hope that nothing blows up, because if it does, it will be very, very, very embarrassing. It's dead. Oh no. Fans on. Okay, well that is the chimes of death, and what that does tell us is that all those little traces that we were looking at before that appear to have little gaps and holes and stuff in them, there are probably plenty more of them out there. So that, I'm afraid, will have to be the end of this particular stream, and I do apologise that that didn't involve a happy chime like it did after Steve's 8-hour marathon recapping. That mine is the disappointment, but I have to say I'm not really that surprised because we have all of those ugly traces going on in there. So I am going to need to go in and work my way through them, but I think that will probably, you know, test the limits of entertainment for a live stream. Yeah, it's, you know, there are positives in that, but yeah, it's you know, not really that surprising. So it bonged, sorta, yeah. I can always connect this one up. Yeah, we'll get this one. I'll connect this one up. Because this one will make a nice noise, and we can just pretend. We can pretend that this is the one that I was working on. So this is my LC475, and I'm going to get my speaker, and I'm going to connect it up here, and I'm going to connect power to it, and it bonged. Yeah, yeah. That's the best I can do, I'm afraid, you know. Yeah, that's life. At least it's recapped. So the next step I'm going to have with that is I am actually going to clean it. And the reason for that is that we know that there are broken traces on this. I mean, that's now fairly clearly demonstrated. It's got broken traces. Now, when it's this badly corroded, I could go in and I could repair all those traces. I could fire it up and it'll start working, and then I put it in the ultrasonic cleaner and it'll stop working. And the reason for that is that an ultrasonic cleaner is a blessing and a curse. It sometimes brings computers back to life because there's sort of, you know, corrosion and stuff like that, but at other times it can actually kill a computer, because if you've got a trace, a corroded trace or a damaged trace that is literally just hanging on by a tiny weeny little bit of corroded copper, you whack it in the ultrasonic cleaner, it cleans all that corrosion away, takes the copper away with it, and where you originally had something that worked, it stops working afterwards. So I really need to clean this now, to just sort of clean all of that old corroded copper away, and that's then going to reveal to me how much stuff needs to be repaired. Now, of course, having said that, we did see an awful lot of corrosion on this. Cleaning it might actually fix it. That, yeah, well, that can be seen maybe in my next stream when I have when I've sort of cleaned it all up. I might do another stream and we can see whether this one actually works after that. But anyhow, it was recapped. Not necessarily fixed, but it was recapped. And I hope you all enjoyed it, and I do thank you all for hanging around for 2 hours. So yes, thank you very much, and thanks for all the support, and you know, do like the vid if you haven't, and I'll thanks for being part of my very first stream, and I will see you next time. Bye now. End.